Dear student, today we'll learn about this chapter, that is chapter 3, motion in a straight line. It is under class 11 science physics. And now under this chapter we'll discuss the subtopic, that is kinematics, next rest and motion, then frame of reference, number 4 concept of point object, that is particle, and number 5 position of an object. We'll start this chapter with kinematics. So we'll clear all the points, all the subtopics one by one. So watch the video till the end. First of all, which we are going to discuss, this is under a branch of physics known as mechanics. Mechanics is a branch of physics in which we are dealing about the forces on an object and motion. Force and motion we are dealing with, and this type of branch are called mechanics. Mechanics can be divided into 3 categories. It has also 3 branches. Number 1, first it is statics. Number 2, that is kinematics. Number 3, that is dynamics. Now statics. Statics is a branch of mechanics in which we are dealing with an object which is at rest. Actually, this type of knowledge is very important for building bridges or different type of construction, and it will actually give you the state of equilibrium. Now I will give you one example. It will help you to understand the subject matter of statics. So I'm drawing one glass in which some water are there, and it is very obvious that the forces are acting on the water inside the container. What type of forces are acting? Gravitational forces are acting. It is vertically downward. Pressure from the atmosphere is also applying on the top surface of the water. So it is the atmospheric pressure which is acting on the surface of the water. And some pressure already given by the solid container to the water. So under these so many forces are acting. So under these so many forces, the water in the container is in a static condition, that is in equilibrium. So these type of things are studied in statics. Now kinematics. Actually, the meaning of kinematics is that it is a motion. It is the study of motion in which the cause of motion we have neglected. We will not deal with the cause of motion, but we will deal with the parameters of the motion like distance, speed, change in speed, acceleration, and time, etc. So in this branch of mechanics, we'll deal with the object, and we have considered it is no shape, no size. Actually, size and shape we have neglected here, and of course mass. We'll only deal with the physical quantities like distance, speed, change in speed, acceleration, time, also displacement, velocities, or also if we consider direction. The third topic, that is the dynamics. The dynamics is a branch of mechanics in which we will discuss about the cause of motion and also laws of motion. In this branch of mechanics, forces will be applied. We'll consider the mass as well as. So in this branch of mechanics, cause of motion, we'll just discuss about the cause of motion of the object, and laws of motion also. So we will emphasis only on the kinematics, that is distance, speed, change in speed, acceleration, without going deeper into the cause of this motion. Next topic, that is second. Now the topic is rest and motion, and there are 2 states of motion, that is one is rest and one is motion. Absolute rest and absolute motion are not possible. Absolute rest and absolute motion are not possible. We cannot talk about absolute rest and absolute motion. What we call about, that is a relative with relation to others. I am giving you one example. Suppose I am standing here, and you can say about what is the state of motion now? Now I am in rest. Why you have considered I am in a rest? Because with respect to the wall of this room, with respect to the board, and with respect to the surroundings, I am standing. But actually, am I in a rest condition? If any person is observing me outside the earth, actually I am on the earth and earth is revolving around the sun. So any observer outside the earth he will observe me that I'm moving, I'm revolving with the earth. So am I now in rest? No, now I'm in motion. So with respect to my room, I'm in a rest condition. With respect to observer outside the earth, I'm motion, which is correct. Both are correct. If we consider the surroundings, with respect to my room, I'm in rest, it is correct. With respect to the observer who is outside the earth, with his concept, I'm in a state of motion, it is also correct. So that's why I'm telling it is a relative concept. When you are making a relation with respect to the surroundings, then your motion, state of motion can be changed. An object may be considered as rest with respect to another object, and it may be considered as moving, is considered as in motion with respect to another object. So an object may be considered as rest with respect to another object, and the same body may be considered as motion with respect to another object. So what you call about the rest, it can be motion with respect to the surroundings, with respect to the neighbor. So that's why absolute rest and absolute motion is impossible. And we talk about the relative motion. Actually all the bodies are moving, and that's why relative motion is the correct word instead of absolute motion. Then what is the definition of rest? What is rest? So the definition of rest is that an object is said to be in rest if its position does not changes with the surroundings with the passage of time. An object, and what is motion? Then object is said to be in motion if its position changes with the surroundings with passage of time. Now we'll go to the third topic, that is frame of reference. So I have told you, I'm standing here, one can say the state of motion is rest, and the another person which is far away from the earth, he can also tell me my state of motion as moving. I'm in a state of motion. So it depends upon the place from which the observer is observing and measuring. So that's why that place is known as the frame of reference. Suppose I'm traveling in a train, and the other passengers also traveling in a train, and in my front seat passengers are seated, and I am also in the train, I am also in a sitting condition. So what is the state of motion of the nearby passenger who is sitting in front of me? We can call he is in a rest condition with respect to me. With respect to the same compartment, we are judging the motions of a body, of an object, with respect to some places, and now this place is the footboard of the train, the compartment of the train, and during the motion the distances between me and that person is not changing. Time is passing, time is elapsing, but the distance in between them, the positions of the person with respect to the compartment from the window, the distance from the window, the distance of that person from the roof is not changing. That's why you call that person is in rest with respect to the footboard or the compartment with respect to the compartment. This compartment, what we have considered, is known as the frame of reference. But what will actually happen if this train is moving in a railway track and the passengers who are sitting in a platform, they will observe the train is moving, we are moving, and that person, which is our consideration, is moving in a particular direction. So what will be his consideration, who is sitting besides the platform, which is sitting in the platform? He can talk about that passengers is in motion. So now the place from where he is judging, he is making the calculation, he is making the observation, that place, that ground is known as the frame of reference. So when the frame of reference changes, the state of motion of an object also changes. So that is known as the frame of reference. This frame of reference is a place or region from where motion of an object is observed and measured is called the frame of reference. Frame of reference can be two types. It will be number one, it will be inertial frame, and now non-inertial frame of reference. Actually, when we talk about the body is moving or not, a body is rest on the earth, actually always we have taken the frame of reference as the earth ground. The ground we have taken the frame of reference in which we are always considered the body's state of motion. Now we'll go to the concept of point object. Concept of point object. Actually, in our physics, we have considered all the bodies as a point. Then our calculations will be easier and we can easily deal with this. But in our realistic life, we have seen a train with 15 compartments, a train with 10 compartments. Is it really a point object? No. It will be a long train. We cannot consider as point object. It is the extended object. But the situation, if we consider the situation, then we consider the long train as a point object. I will give you one example. Suppose the train is moving from Howrah to Chennai. Actually, the distance between the Howrah to Chennai will be 1600. The distance between them is 1000. Kolkata to, it is Howrah to Chennai. It will be 1600 kilometer, approximately 1600 kilometer. So what is the length of a train? It will be, suppose, 500 meter, half of a kilometer. So with respect to the train, the distance we cover is longer. So with respect to the longer distance, the length of the train is very small. In this case, we can consider the train as point object. So what is point object? So point object an object can be considered as point object when its size is very small, or object size of the object is small compared to the distance traveled. Now what is body? What we call body? That is not point object. Body is an object whose size length is not small compared to the distance traveled and it can change the motion parameters. Then we call it is a body. So what example I have given you, the 5 compartment train will reach Chennai. Suppose at a particular speed it is moving, the distance is also fixed, so it will take some time. If instead of 5 compartment train, if it is 10 compartment train, then it will take the same time to reach. If it is 15 compartment train, then it will take the same time to reach. When the driver will reach the Chennai station, the guard of the train also reaches the same station. So we can say the motion parameters has not changed. The motion parameters is the time here. They will take the same time if we take the length of the train as 5 compartment, 10 compartment or 15 compartment. So in this case, the train will consider as point object. But the same train, if you consider, suppose there is a pillar and the train is moving this pillar. So how long it will take time? How much time will it take to cross it? For 10 compartment train, it will take 10 seconds. For 15 compartment train, it will take 15 seconds. So you can say the time taken to cross this pillar by this train changes. The parameter changes when the length of the train changes. So in this case, the same train we cannot consider as point object because motion parameter has been changed due to this effect. So that's why which is point object, which is not a point object or body. How can you identify by this definition? An object can be considered as point object when its size is very small or size of the object is small compared to the distance traveled. Which is body? Body is an object which size length is not small compared to the distance traveled and it can change the motion parameter. Now I will give you some example. It is from the NCERT book. At the end of this chapter, some questions are there. It is written, In which of the following example of the motion can be body considered approximately a point object? A railway, number one, a railway carriage moving without jerks between two stations. So as we have already stated, this thing will be, the train will be considered as point object. I have already explained. Now the second question is that a monkey sitting on top of a man cycling smoothly on a circular track. So suppose a monkey sitting on a man is moving in a circular track. So is it the monkey can be considered as a point object or a body? Think about that. So if the circular track, if we take the size of the monkey is very small, how much time will it take to complete the circle? Suppose a particular time will be taken. If the size of the monkey is bigger, then what will be the time to take to complete one revolution by that monkey? Will the time differ? No, same time it will take. If the monkey is standing on the man, how much time will it take to complete the circle? If the monkey is lying on him, then what will be the time taken by the monkey to complete one revolution? In all the time it will be same. So motion parameters has not been changed by the size of the monkey. Here in this context, the monkey can be considered as point object. Third question is that a spinning cricket ball that turns sharply on hitting the ground. Is a spinning cricket ball. A cricket ball spins, and you know when the cricket ball is coming, falls on the ground, and then due to the torque, due to its size, it will produce one torque. Due to torque, it will just changes its direction and move in a particular direction. So instead of taking a big ball, take the small rice, cereal of rice. So if it is coming and falls on the ground, then it will not change the direction. It will falls on the ground and move in the same direction, because it is so small that it will not give any torque on the ground, and that's why the direction of this point body will not be changed. So what is about the spinning ball? So spinning ball will be considered as point object or body. So here the motion parameter changes. In this phenomena, which motion parameter changes? There is direction. When the ball comes and falls on the ground, it will make one torque, apply one torque on the ground, and due to this torque, the direction of the ball changes. This time it will be taken as body because motion parameter changes. So you can consider the previous example. We have taken the monkey. Monkey is a bigger size with respect to the ball, though that was a monkey was a point object. Now here in this phenomena, the ball is considered as a body, not a point object, because motion parameter changed case. The beaker is considered as body. So I have given you so many examples. So that is the concept of point object and body. So in our physics, the equations, the laws has been made for point object. So for extended object, what will happen? So extended object will modify the situation and will make it for a point object. We'll consider the extended object as point object by giving some conditions or modifications. Some amendment will be there for that condition. Now, number 5, the last topic is that the position of an object. Position of an object. Now, to specify, to locate an object, we have to start from a particular point. Sometimes this point is called the origin. Suppose someone asks you, where is your school? So to locate the school, you will name the place of the school. If that person cannot recognize the actual place, then to make him understand, you will start from a particular place which is known to him. Which places is known to him, you will start describing the place of the school from that place. That place is known as the origin. If you find that origin, then your description will be easier, and that person can find the school. That person can recognize where the school is situated. So here the same thing is applied. So to locate the position of an object, we have to first of all make one origin. Next, the frame of reference. Frame of reference. First of all, frame of reference, because we are dealing with the motion in a straight line, so either x or y or z will take, but in a space x, y, z, 3 axes will take. And then where these three axes meet, we'll take the origin. If we take a plane, then two axes will be taken, either xy or yz or zx. But here we'll take either x or y or z. Suppose x axis, and this is the origin. It is 1, 2, 3. So this is actually one dimension. This is actually the frame of reference, that is origin O, and some body, some object is moving in a particular direction along one dimension. We have considered as we have considered the one dimension. So that's why either positive x-axis or negative x-axis. So this way we can locate a position of an object. Suppose an object is situated here, then how will you locate the object? We'll start from origin. Then we'll say it is at 4 units apart in a positive direction. So what is the distance? 4 unit distance, 4 meter. Suppose in SI system it will be meter, so 4 meter. So 4 meter from the origin. But first of all, what we have considered? We have considered a point, a reference point from where we'll give the description. That is the origin. We have started describing the position of an object from the origin. This is actually called the origin. And then distance. How much distance from the origin? That is 4 meter. But you see, there will be also a 4 meter distance. It is also a 4 meter distance. That's why the direction is necessary. So what are the directions in this x-axis? Positive x-axis and negative x-axis, that is positive and negative. So now the direction is in that direction, that is the positive direction. So now we'll reach at this point, that is a point. We'll reach at this point. So in this way we can locate a position or give the position of an object accurately. Now up to this, next subtopics will be discussed in the next video. Thank you for watching my video. Thank you.